Everyone, my name is Kishan and my group members are Jason, Hanming, Kenji and Nicholas. We are from Physics Group 6. In this video, we will be presenting about the AC generator. I will be explaining about the AC generator and the components of it. Jason will be explaining about the working principle of the AC generator based on Faraday's and Lenz's law. Kenji will be presenting about the graphs produced from the AC generator, which is flux versus time graph and EMF versus time graph. Hanming will be presenting about the equations which are related to the AC generator. After that, Nicholas will be presenting about the back EMF. And last but not least, Hanming will also be touching about the modifications done to the conventional AC generator. AC generators. AC generators are devices that converts mechanical energy to electrical energy. It generates an alternating voltage by rotating a coil in the magnetic field. AC is meant by alternating current, which is a current that reverses its direction at regular recurring intervals. AC generator was originally designed by Nikola Tesla. This is an example of an AC generator. It consists of a stator and a rotor. A stator is the stationary part of the machine. The rotor is the rotating part of the machine. This is the stator, the outer part. The inner part is the rotor. The stator is to convert the rotating magnetic field to electrical energy. The rotating magnetic field is generated by the rotor cutting through the magnetic field. See on the right, this is an AC generator diagram. In this diagram, you are able to see the components of an AC generator. It consists of a concave magnet, which has north and south pole on each end, an armature, and a current collecting arrangement which consists of slip rings and carbon brushes. The armature is made of soft iron core, which a coil having a large number of turns of insulated copper wires around it. We use concave magnet instead of a normal magnet is because concave magnet produces a radial magnetic field. Now, we're gonna talk about the functions of the carbon brushes and slip rings. Carbon brushes collects the current from the moving parts and feeds the stationary current, whereas the slip ring is the electromechanical devices that allows the transmission of power and electrical signals from a stationary to a rotation structure.
So today I'm going to talk about Faraday's law. Faraday's law of induction is a basic law of electromagnetism predicting how a magnetic field will interact with an electric circuit to produce an electromotive force called EMF, a phenomenon called electromagnetic induction. It is the fundamental operating principle of transformers, inductors, and many types of electrical motors, generators, and solenoids. The Maxwell-Faraday law equation is a generalization of Faraday's law and is listed as one of Maxwell's equations. So, what is Faraday's law? Basically, when there is changes in magnetic flux, an induced electromotive force will be produced. The higher the rate of magnetic flux, the greater the magnitude of induced electromotive force. So let's move on to Lenz's law. Lenz's law is a change in current because by the direction that the current flows due to the change in magnetic flux. The current will go in a certain direction to create against the change in magnetic flux with its own magnetic field. In most electrical and generators turn mechanical energy into voltage via magnetic induction. In Lenz's law, it shows that why the voltage produced by such generator alternates sign. So how do we determine Lenz's law? To determine Lenz's law, the direction of an induced voltage or current is given by Lenz's law. Do remember that a current running through a coil wires create magnetic field. For instance, the induced current flows so that its magnetic field opposes the change in magnetic flux of the loop. Besides this method, we can also use the right-hand rule or the Fleming left-hand rule. Thank you. So move on to next, the working principle of a generator. When both laws are combined, it will combine as an AC generator. An AC generator works on the principle of the electromagnetic induction. When there is a relative motion between a coil and a magnetic field, an electric current or EMF induced in the coil bounce of an AC generator. As you guys can see in the video or the animation, whatever you call that, an AC generator has the armature of A, B, C and D. It is a rectangular coil with many turns wound around soft iron core. A shaft, it can rotate rapidly with a magnet, and it may be strong permanent magnet with concave poles to slip rings and connected to a galvanometer. Galvanometer ensure working of an AC generator. When the armature rotates between poles of the field magnet, the magnetic flux link with the armature changes continuously. As a result, an EMF is induced in the armature. This in turn produces an electric current through the armature and the galvanometer and through the slip rings. And the galvanometer needle will swing between negative and positive values, and this means that there is an alternating current is flowing through the galvanometer.
Hi, today I would like to talk about two graphs which is related to EMF and magnetic flux and time. So in the first graph, this is a flux versus time graph, and we can see that initially when the coil is horizontal and parallel to the magnetic flux, there is cutting of magnetic field lines. Thus, the magnetic flux will be in zero and there will be EMF produced. When the coil rotates to 90 degrees, the coil is vertical to the magnetic flux. Thus, there will be no cutting of magnetic field lines and there will be no EMF produced. When the coil rotates to 180 degrees, it is the same position as the initial. Hence, the cutting of magnetic flux is maximum and there will be EMF produced. And when it comes to the coil rotates to 270 degrees, it is the same rotation as the 90 degrees, so the coil is vertical to the magnetic flux. Thus, there will be no cutting of magnetic field lines and there will be no EMF produced. But as the rotation of the coil changes the opposite side, the magnitude of the magnetic flux remains the same, while it is in negative sign due to the changes in direction. And next, the coil rotates back to 360 degrees and it is the same as initial. Thus, there will be cutting of magnetic flux and the magnetic flux will be in zero and there will be EMF produced. And next, I would like to talk about EMF versus time graph. So as you can see that when the coil is at initial, there will be cutting of magnetic flux, and when there's cutting of magnetic flux, there will be induced EMF produced. Hence, the induced EMF will be the highest when the magnetic flux is zero. And after that, when you can see that the coil rotates to 90 degrees, there will be no cutting of magnetic flux. Hence, the induced EMF will be zero. And as you can see that when the coil rotates to 180 degrees, there will be cutting of magnetic flux. Hence again, there will be induced EMF produced. But as you can see that the changes of direction influence the sign of the magnitude, but the magnitude of the induced EMF will be the same. And as you can see that when the coil rotates to 270 degrees, there will be no EMF produced as there is no cutting of magnetic flux. And lastly, when the coil rotates to 360 degrees, there is cutting of magnetic field lines. Thus, there will be EMF produced. And this time, as the direction changes again to the initial, the sign will be in positive, but the magnitude of the induced EMF will remain the same. That's all. Thank you.
Now I'm going to talk about the equations that is related to the AC generator. And this equation shown is the measure of the magnetic flux. Now, what is magnetic flux? Magnetic flux is used to describe the amount of magnetic field lines that passes through a given conductor, and is quantitatively given by this equation right here. This represents the magnetic flux that you're supposed to measure, and the unit for the flux is Webers. As you can see right here, this is the SI unit, by the way. And the B represents the magnetic field strength. A represents the area of the coil that is connected to the power source, and the cos theta is the angle between the field lines and the normal to the coil. The second equation we're going to talk about is the measure of the average induced electromotive force, as you can see right here, which is also measured in voltage. And N represents the number of turns in a coil that is connected to the power source. And the delta this thing over delta T is the measure of the rate of change of magnetic flux against the rate of change of time. And that is the only two equations that is related to the AC generator, and that'll be all for equations.
Hello everyone, now I'm going to talk about back EMF. Now what exactly is back EMF? Well, back EMF is the electromagnetic force that opposes the change in current which induced it. When a motor is spinning, its coils turn inside magnetic fields, and a coil turning inside a magnetic field induces an EMF. This is our back EMF, and it acts to counteract the applied voltage that's causing the motor to spin in the first place, and thus this reduces the current flowing through the coils of the motor. Faraday's law states that when the magnetic flux linking a circuit changes, an EMF is induced in the circuit proportional to the rate of change of the flux linkage. As we can see from the graphs, when magnetic flux is zero, EMF and in turn back EMF is at its greatest, and when EMF is at its lowest, aka zero, magnetic flux is at its highest. The voltage and EMF graph has a similar pattern, with the EMF graph being inverse to the voltage graph. However, there's a slight alteration in that the amplitude of the voltage is higher. Now, how do we reduce this effect of back EMF? Well, back EMF scales with the spinning speed of the motor. So if a motor is left alone spinning really fast, its back EMF would be greater. However, if the motor is connected to a load like a circuit or a sack of bricks, this decreases its spin speed, which in turn also reduces back EMF.
Move towards the technological advanced era, many modifications have been done to a conventional AC generator, such as an inverter generator. Now, what is inverter generator? An inverter generator electronically throttles the engine up and down to meet demand instead of running full tilt all the time. The resulting improvement in efficiency means that for the same size of gas tank, you won't have to fill up as much as often. An inverter generator produces lower emissions and it is very quiet. Some said it is so quiet that you can even carry on a conversation next to a running AC generator. Now, the three-phase alternator that is normally found in inverter generators produces a larger current compared to a normal single-phase alternator that is found in old or more traditional AC generators. Now, how does the inverter generator work? The inverter generators work by generating three-phase AC power at a high frequency. It is then converted to direct current and then alternating current. and back to direct current that can be used by the electronic equipment and appliances. The advantage of using this inversion is that it maintains a constant flow of current to your appliances. This output from the inverter generator is called the clean power, which means stable and consistent current and a stable sine wave delivery. This will not cause the fluctuation in voltage which happens with traditional generators. Sudden fluctuation in power is very dangerous, as many high-tech and sensitive electronics such as computers will often shut down immediately. Most inverter generators can be repaired with another identically sized unit to double your power capacity, which is a lot. Now, some examples of an inverter generators is the Honda inverter generator. As you can see, it is very small and portable, when you can carry around to almost anywhere. And that is all about the modification that can be done to a AC generator, and I hope you'll enjoy.